quantifying the 84th percentile, or D84 for short, in an ephemeral channel. In this example, the Rambla Alias near to Carboneras in southeast Spain is used as a locality. Ephemeral channels are classic features of arid and semi-arid environments and are subject to flash flood events. These flashy systems experience floods across a broad spectrum of time. The recurrence is very much dependent upon the geography of the region. In the case of the Rambla Alias here, small-scale flow may be experienced a number of times per year during the wetter winter season, but catastrophic flash flood events, as seen in the earlier YouTube video, only occur once every 50 to 100 years. In order to generate an estimate of discharge rate during flash floods, we can apply some relatively straightforward mathematics to data collected in the field. Key data to collect during fieldwork are particle size distributions of the class that make up the channel bed. As many as 100 individual classes are measured in any single transect of a channel. These are collated into a spreadsheet and analysed statistically. When measuring a class, it is the B-axis, or the axis of intermediate length of a class that is of importance. The longest axis is named the A-axis, and the shortest axis is named the C-axis. On the screen here, we will see the B-axis marked as a green line on the long pale colour class in the bottom right-hand corner of the image. A spreadsheet containing these data is provided for you. On screen is a short introduction to the initial steps you are expected to make in order to begin your analysis of these data. After performing the first 3 steps, you will then be expected to follow the written instructions for yourself. First of all, open the spreadsheet entitled Ephemeral Exercise Sheet. You will see on the first worksheet 2 columns of data. These are particle size measurements collected in the Rambla Alias. The first step is to generate descriptive statistics for these 2 sets of data. Navigate to the Data tab in Microsoft Excel and look for the Data Analysis Toolpack located in the top right hand corner. If you cannot find the Data Analysis Toolpack, pause this video and use the built-in help function to activate this feature of Excel. When you've opened the Data Analysis Toolpack, select the option for Descriptive Statistics from the menu and click OK. Next, you will need to determine the input range. Select the entire data range for the first transect for now. Now, ensure you have selected the Summary Statistics and Output Range checkboxes in the Options box. Place the output range somewhere logical within your spreadsheet, as shown in the next slide. Click OK to perform the descriptive statistics analysis now. Importantly, at this stage, you should label your newly generated statistics. It is always good practice to label your data analysis as soon as you perform them to make sure your records are in good order and can be traced through at a later point in time if need be. Now repeat this descriptive statistics step for the second transect for yourself now. Finally, you will need to analyse the data for the 84th percentile, or D84. Excel has a built-in function to perform this analysis. Use the function detailed in the text to obtain the 84th percentile for the first transect. And remember that the percentage is input as a decimal in Excel, so 84% becomes 0.84. Again, you will need to calculate the 84th percentile for the second transect too. You have now successfully calculated your D84 values for input into the Darcy-Weisbach equation to estimate ephemeral channel discharge.